know, mensuration is an aspect of, mathematics where we study the volume, the area, and then the perimeter of what? Of plane figures. Okay, that is about mensuration. And the plane figure, we have the 2-dimensional figures and then the 3-dimensional figures. All right. So the figure that are flat, okay, is the 2-dimensional figures. Okay, and then you have the 3-dimensional figures. All right. So the 2-dimensional figures can be circle, it can be rectangle, it can be, trapezium, it can be rhombus, it can be square, it can be triangle, parallelogram, it can be kite, and then this aspect we are going to start with the 2-dimensional figures. Okay. And then the 2-dimensional figures we are going to start with circle. So circle, we are going to learn, first of all, you have to know all the parts of a circle. When we say we are learning about circle, we have to know all the parts of what? Of a circle. Is that okay? We have to know all the parts of a circle. So let's look at it, know the parts of a circle, and then we continue from there. So if I have a circle, okay, when I go around the entire distance around the circle, it is called what? The circumference. I know some of us know it. Circumference of a circle. Okay, circumference. All right. And then every circle has the center. Okay, every circle has a center. So with the center, the distance from one end, or the distance from the center to the circumference, is called the radius. From the center to the circumference is called the radius. And then if you have a line, so the line from the center to circumference, the straight line is the radius. And also a straight line that passes through, all right, the center from one end of the circumference to the other end, we call it the diameter. The diameter. So we have the diameter, and you realize that the diameter, you see, from here to here, because from this side, from the center here to the circumference, it's also a radius. Okay, a circle has just one center, and then from the center to any point of the circumference of the circle becomes the radius. So from center here, it's because it gives the same distance from the center to the circumference. It's the same distance for every circle. So realize that when you are using a compass to draw a circle, you see, the moment you stand at the center and you draw from the center to the circumference, at any point of the circumference, give the same distance. All right. So we can say that our diameter is equal to 2 times of our radius. So the diameter is 2 times of the radius. All right. So we have our diameter also like that. Okay. Then another thing we can also look at. We are going to draw a lot of circle. Okay. So that we can use that to illustrate. When we have a circle, from one end of the circumference to the other end, you know, if it passes through the center, it becomes the diameter. But if it doesn't pass through the center, then we call it what? Chord. So from one end of the center circumference of the circle to the other end, all right, is the chord. If it passes through the center, it becomes the diameter. So the chord is a straight line from one end of the circumference to the other end. So this is what we have. We have our chord also here. And you realize that the chord has divided this particular circle into 2, but not 2 equal parts, all right? Into 2. So we have what we call a segment. A segment consists of what? A chord, this particular chord here, and then a portion of the circumference of the circle. Okay. Before we come to the segments, let me talk about an arc. You see, let's say here is A and here is B. If I just take a portion of the entire distance around the circle in the circumference, but if I just take a portion, okay, let's say this particular side of the circumference, If I take a portion of the circumference, then that becomes what? An arc. An arc. So an arc is like this. Just a portion. You see, those times when you are doing construction, okay, so you draw an arc. So you realize that you put your compass and then you don't draw a full circle. Just draw a circumference, okay, a portion of the circumference. You don't draw a full circle, okay. So the line that you draw, okay, becomes the arc, because an arc is not a full circumference of a circle, but just a portion of the circumference of the circle. All right. So this is an arc. But the arc, you realize that the place that I have shaded is smaller, and then this side is bigger. So the smaller side is called the minor arc, and the bigger side we call it the major arc. All right. So with a portion of the circumference of the circle, the smaller side is the minor arc, and the bigger side is the major arc. All right. And you see the chord, as I was saying, the chord has divided this circle into two. We have the upper part here and then the lower part here. Okay. Then when the chord divides the circle into two, okay, both sides is what? A segment. But the chord does not divide the circle into two equal parts. All right. It is a diameter that divides the circle into two equal parts. But chord will divide into two. Okay, but not equal. So the bigger side will be called the major segment, and then where I have shaded is the minor segment. Okay, so a segment actually consists of a chord and an arc. So if you want a segment is chord and arc, either the major arc or the minor arc. Okay, so the whole space here, okay, where I have not shaded is a segment, but the major one. So the segment consists of the chord here and then the arc. All right, that is about a segment, a chord and then an arc. All right. Then, as we were saying, we also have some parts that we have still not done. You see, when I draw a circle like this, everything within the space covered by the circle is called the area of the circle. All right, so this particular space here is the area of the circle. When you have any portion of the area formed by two radii, okay, radius, when you have singular is radius, plural is radii, two radii. So let's say I have a portion of the area and it is formed by, this is radius, this is radius. So the entire space here within the circle is the area. If I have a portion formed by two radii, then it becomes what? We call it a sector. Okay, but the sector, you see that the upper part here is bigger than the lower part here. So here we become a minor sector, and the top here becomes what? The bigger side becomes what? A major sector, So here becomes a minor sector, and the top here becomes a major sector. So let me see how sector is. A sector is like this. You see. So a sector consists of what? Two radii and an arc. And then here is the center because it's a radius. Okay. So a sector consists of, so let's say here my center is O. A sector consists of two radii and an arc. So that is about a sector. So this is the minor one. If it's a major one, you see that the major one is like this. So this is bigger than this. The reason is that this will cover the angle at the center. This will be more than this one. All right. Sure. So the second, this is also radius, and this is also arc. But you realize this is the major arc because it is a bigger portion of the circumference of the circle. All right. So a sector is a portion of the area of the circle. An arc is a portion of the circumference of the circle. All right. And as we know, when as we are privy to, a diameter divides a circle into what? Into two, because the line passes through the center. So if a circle is divided into two, we have the semicircle, and this is also a semicircle. All right, semicircle. Semicircle means half of what? Half of a circle. Half of a circle. Okay, and then when we divide a circle into four, when a circle is divided into four, so it will become like this, and it will form a right angle. So that here is 90, another one is 90, 180, 90, 90, and becomes 360. So the entire degrees, or the angle of a full circle, is what, 360 degrees. So this is a quarter of a circle, and quarter of a circle is called quadrant. So quadrant is a quarter of a circle. Half of a circle is a semicircle. All right, and then a line from one end of the circumference of the circle to the other is a chord. The distance around a circle is called what? Circumference. And note, circumference of the circle is also known as the perimeter of a circle. Circumference of a circle is the same as what? Perimeter of a circle. Perimeter of a circle. That is, circumference of a circle is the same as perimeter. When you talk about perimeter, we are talking about the distance around a plane figure. All right, so this is about the paths of what? The paths of a circle. Okay. Okay, so let's continue. So now we are going to look at circumference, how we calculate for circumference of a circle. The circumference of a circle. Circumference of a circle. So one thing we should know, that for every circle, if I draw a circle like this, okay, the ratio of the circumference to the diameter is constant. The ratio of the circle, and for every circle, it has a ratio, a constant ratio of the circumference and a diameter. So if you like, take your protractor, draw about 20 different circles and measure the circumference, measure the diameter, you see you get the same answer. Okay, so you can say that the ratio of the circumference to the diameter is constant, and ratio can be written as what? C over D, and the constant is called pi. Okay, so pi, right? So circumference of the diameter is equal to pi, and pi becomes our constant. Okay, and then for pi, pi is 3.143, and then continues like that. All right, it's irrational. And then if you want to write as rational, convert, then becomes what? 22 on 7. 22 on 7. Okay, so that is about pi. So mostly you'll be giving pi in the question, and when you are giving pi in the question, either in a certain decimal place, or as a rational number like this, 22 on 7. All right, so since we know, let's come to the the circumference. We said that the ratio of the circumference of the diameter is pi. Therefore, so if my circumference is c, then the circumference of the diameter is pi. So therefore my circumference will be what? Pi d, where the d is what? Is the diameter. So circumference of the circle is pi d. And what is diameter? We know that diameter can also be what? It can also be 2 of the radius, or 2 radii. So my circumference becomes what? It can be 2 pi r, 2 pi r, where the diameter is the 2r. So that 2r times pi will give me 2 pi r. So that is about the circumference of a circle. So as I said, I'm not going to work anything here today. I'm just going to give you just the whole concept of mensuration on circle, Then you go and take your various textbooks and then you solve question. Now let's look at, so that's the formula for finding the circumference of a circle. Either pi d, depending on if you are given a diameter, then use the pi. If you are given a radius, then use 2 pi r. Alright, 2 pi r. Even if you are given diameter, you can divide the diameter to also find the radius. Radius will be what? Diameter divided by 2. So you can divide the diameter into 2 and we use this particular formula here. Alright. Okay. So if you are given the radius, you can multiply the radius by 2. Even if it is in this formula, 2 times the radius is equal to the diameter here. Okay. Now let's look at the area. Area of a circle. Area of a circle is given by what? Pi r squared. Pi r squared. So the formula for the area of a circle is pi r squared. Pi r squared. Okay. So circumference 2 pi r, area pi r squared. Let's move on. Then let's go to the length of an arc. Length of an arc. So if I have a circle here, and we say that what is an arc? An arc is a portion on the circumference of what? Of the circle. So we're going to look at the length of an arc. And if you want to find the length of an arc, okay, the length of the arc, okay, is proportional, okay, to the angle the arc subtends at the center of the circle. All right. So if I have an arc here, let's say my arc is A. This is my arc AB. That is from here to here. So the length of this arc is the same as what this particular arc, the angle it will sustain at the center of the circle. It's proportional to the angle is sustained at the center. So let's say here is the center. The center is O. Okay, the center is O. Or what we can say that, okay, the ratio of the length of this particular arc here to the circumference of the circle is the same as the ratio of the angle here, okay, to the entire angle of what? Of the circle. So the ratio of the arc here, the minor arc here, or even the major arc here, to the entire circumference of the circle is the same as the ratio of the angle here, okay, to the entire angle of the circle, which is 360 degrees. Okay, so the angle at the center is going to help us to find. All right, so this is my minor arc, and then the bigger part here becomes. So let me shade this place so that so that you see the shaded place, and then the bigger part here is called my major arc. Okay, so the angle is subtended at the center is very key, very important to help us to calculate for the length of the arc. Okay, so you will see if it's a major arc or a minor arc. So if, let's say, the angle this particular arc subtended at the center is theta, if it is theta, then what will be the length of the length of the minor arc? The length of the minor arc. Okay. Since the length of the arc is proportional to the angle it sustained at the center of the circle, then the arc doesn't take the full circle, it takes a portion of the angle at the center. So I would say since the arc is also a portion of the circumference, okay, the arc is a portion of the circumference. So I will take the angle the arc sustained at the center, divide by what? 360 degrees. That is the total angle of a circle. Multiply by, since the arc is a portion of the circumference, I'll multiply by the circumference of the circle. That is 2 pi r. So the length of the minor arc here is theta over 3 times 2 pi r, because we multiply by 2 pi r because 2 pi r is what? The circumference of the circle. Okay, let's look at the length of the major arc. So if here is theta, then what angle will be here? Okay, this is angle around the point is what? 360 degrees. So if here is theta, this here will be 360 minus theta. Alright, so the angle of the major arc is 360 minus theta. So that will be 360 minus theta over 360 times 2 pi r. So 360 minus theta over 360 times 2 pi r times 2 pi r. Okay. So that is, so in short, what we are saying is that the length of an arc is the angle the arc subtends at the center divided by 360 times 2 pi r. Okay, because we have already used here theta, that is why I'm saying that here will be 360 minus theta. Assuming that I use it as theta, then here will be what? 360 minus theta. So it is not constant that, okay, 360 minus theta, then you know. What you should know, we are talking about the angle at the center. So the angle at the center, the angle the arc subtends at the center, divided by 360 times 2 pi r. That is what we are talking about. So that is the length of an arc, the length of an arc. Alright, so when you are doing a question, I know you can do. So now let's go to you are done with the length of the arc. Now let's go to the area of a sector. Area of a sector. Okay. So a sector is a portion of the, so a portion of the area of a circle, all right, formed by two radii. So this is my, so here is A, here is the center B. So this is my sector. Okay, and then a sector 2, the area of a sector is also proportional to the angle the sector subtends at the circumference of the circle. So this is my, also my sector. So if the shaded portion is the sector, a portion, so a sector is like this. So the sector here is the minor one, so the minor sector, and then this place is the what? The major sector. So the minor one is like this, and then the major one something like this. Looking from the diagram there, something like this. All right. Okay. So how do we find the area of a sector? The area of a sector. So area of a sector. Area of a sector. So here let's look at the minor and the major, right? Of the minor sector, okay, is equal to area of the, let me change the marker, sorry, area of the minor sector. Okay, so what angle that the minor sector sustain at the center? It is theta on 360. The sector is a portion of the area of the entire circle. So area of a circle is pi r squared. It means the area of the minor sector will be theta over 3 times pi r squared times pi r squared. Times pi r squared. So look at the angle the sector subtends at the center, divide by 3, multiply by pi r squared. Pi r, because a sector is a portion of the area of the circle. So arc is a portion of the circumference of the circle. So multiply by 2 pi r. Sector, a portion of the area. So you multiply by pi r squared, which is the area of the circle. Alright. So let's look at the area of the major one. So area of the major sector. So if I'm looking at the major sector, then I look at the angle here, which is 360 minus theta. So 360 minus theta over 360 times pi r squared. Okay, so if the angle here is theta, then you do 360 minus theta. So we look at the angle the major sector subtend at the center, which is 360 minus theta divided by 360 times pi r squared. All right. So we are using pi r squared because a sector is a portion of the area of the circle. I believe you got it. Okay. And now let's look at the perimeter of a sector. Perimeter of a sector. Perimeter of a sector. I believe you got this one, so I can clear. Okay. Perimeter of a sector. Perimeter of a sector. The same sector. Perimeter of a sector. Perimeter of a sector. So what is the perimeter of a sector? We need to this is so the sector. Let's look at what the sector consists of. Okay, so this is a sector. If assuming this is the center, 2 radii, and this is what an arc. So this is a minor. So I can say minor arc. So if I'm looking at the sector from this, it is a major sector. Then, so this is my major arc. All right, major arc. And then this is my 2 radii. So you realize that the perimeter, when you talk about the perimeter, we are talking about the distance around what? The figure. So if I look at the distance around, these are all sector. A sector consists of 2 radii and an arc. 2 radii and an arc. So if I look at the perimeter of a sector, so we are looking at perimeter of a sector. All right. If the perimeter of a sector, then the distance radius plus the length of the arc. Radius plus the length of the arc. You get it? So perimeter of a sector becomes r plus the length of the arc. Okay, the length of the arc. Length of the arc. So r plus r will give us 2r. What is length of the arc? The angle the arc subtend at the center divided by 360 times 2 pi r. Times 2 pi r. So the angle is subtend is theta. Okay, so whatever, if it is major or minor. The other time I used 360 minus theta because I use the theta for the minor one. So to get the angle for the major one, it is 360 minus theta. Okay, but the general thing is that it is the angle the sector subtend at the center divided by 360. So let's not confuse ourselves. So the perimeter of a sector is the distance around the sector. So r plus the length of the arc. R plus the length of the arc. So the angle here represents the angle at the center of either it is a major arc here, or if it's a major sector, or if it's a minor sector. Yeah, they are looking at the angle at the center. Divided by 360 times 2 pi r. And then down the 2 pi r, this is the length of the arc, because radius plus the length of the arc will give me the perimeter. That is the distance around the figure. So this is about the perimeter of a sector. Perimeter of a sector. Perimeter of a sector. Okay. So I want us to pause here with our studies today, and then we will continue another time.